do I have the file? Let me show you so you can. Give me, hang on a second. Okay, I'm screen sharing so you guys can see, right? Can you see? Can you see my screen?
Right now, no, sir.
No?
No.
Hang
No.
on. Hang on a second. Nothing? Can you see anything now?
Yes.
Yes, now I can
Yes.
see.
Okay, let me try it again. Can you see it now?
Yes, Ajahn, right now.
Yes, Ajahn.
Okay, so this is going to be your first assignment. Oh, hang on, it's shutting down. Okay, so actually it's part of the in chapter problems. I'm loading it. Okay, so but you can read it. I upload that in the chat already. I'll officially post in the assignments tab moments later from now. Okay, but I'm just gonna explain a little bit here. So here, I didn't do this in PDF, so I don't have any pointing, but here you have a core showing, and I'll give you some hints before you guys can start. This is going to be in class, so try to, do it on your own, and you can ask friends, of course, but, try to do this on your own as much as possible. Let me briefly draw this core a little bit, okay, and I'll explain it to you in a moment. See, so, but as you can see in this problem, I didn't draw this right. Your core has only one binary gap, and this time the winding is on the left side, okay, and the core are not symmetrical. As you can see, the center leg is a little bit larger than the rest, left and right. Okay, I'll come back to the starting point in a moment. Okay, again, I got this up end of chapter, but things gonna change a little bit because in your textbook, it's considering a fringing effect. Here we don't do that. Okay, and then I'm asking you to find only the flux in the 3 legs. Okay, let's do that. Okay. Wait a second, I can't stop presenting. Okay, can you see my notes now? Yes?
Yes, Sir John, we can.
Okay.
Yes, sir.
All right. So this is going to be your assignments to do today. I'm asking you to find out the flux in each path. I'll give you the first clue. Okay. And then you have how much time you guys need? Maybe like 40 minutes. Okay. So here. So let's start off with sketching the circuit. Then you must do the rest on your own, okay? So this is an easy assignment. Please, like I said, try to do this on your own. You have to get understanding what we're doing, okay? So this is the core, okay? And notice that this is not there. When air gathering center, I forgot the number. Let's just say G, okay? And it's kind of like almost symmetrical, okay? Because here you have 9 centimeter, 25, but the center lake's larger, 15, 25, 9, and then 9, 25, and then 9. And then the core depth is 5, all in centimeters, okay? Now, we want to find out the flux in each leg of the core. So meaning, assume this is going up, so phi left, okay, and then come there, split into 2 paths, okay, phi center, phi right, and then joining again, complete the path, okay? So you start with your source. So this is how you sketch your magnetometry force, okay? Going up, phi left, passing through. Now, you have to look at the path first. This is very important. This time, the length of your phi out is not only this part, because phi out starts from, let me get a red ink. Starts from this point. See? Because there's only single path here. Same path, upward towards the right. And then that's where the phi out starts to split into 2 parts of center, left. Where left flux is split into center and right. So this would be your left length. Okay, get that? So here, this is R left. Okay, for that, and then splits down to the center. And then the right path. Again, you look at the center from the here down to here. That's it. But 2 materials, the core and the gap. So it needs 2 RC and then RG. Okay. And then your right. See, I get a different color. Well, no, still red. But the right path is this one. Starting from here, again, going out, from here, down here, see? So same thing here. Come down, RR, and that completes the path. Okay, no fringing effect. Okay, so this is how you start, and then you will calculate each reluctances. And don't forget, reluctances are length over mu A. So the cross-sectional area of each leg are not the same. See, this one cross-sectional area is what? This one is larger, this one is what? You'll find that out, okay? So in class assignment, you start calculating each reluctances, show me the details in your own handwriting. You can do this on paper or electronics or tablets, whatever you want to do, okay? what I need, what the assignment is asking for is each flux, phi left, phi center, and phi right. That's what I need from you guys. Okay. Do this, please. How much time do you need? 40 minutes, okay?
I think so, Ajahn.
Okay. So it's gonna do about, because I need time to give you solutions. So that way you kind of like it's fresh in your head. So you would understand what I'm talking about. So I'm gonna set the date, the due time is due today, and the time is gonna be, what time is it right now? It's 2, let's make it 2:25. Okay. To submit by 2:25 and do that. This is kind of like to help you guys practice the submission process too. We do that in the assignments, okay? So everyone, please submit in PDF via the assignments menu in your team channel, okay? So you maybe right around, 2:20, you do the process and convert, taking pictures of the stuff, okay? I'll come back and, I'm going to be here. If you have a question, you can just ask, okay? So in the meantime, start your assignments now, and then I'll set up the tab for the assignment number 1 submission. All right. And again, if you have questions or anything you want to talk, shout. Okay. Okay, I'm going to turn off the screen and set up the assignments tab. Okay. Before, there's a couple rules. On your work, I need 4 things. Okay. So pretend this is a page. Okay. And is the course number 2401. I need assignments number 1, your name, your ID. 4 items. Has to be on the top of the page. Okay. Everything must be done in your own handwriting, either on pen, pencil, or what do you call it? Electronics pen, Apple Pencil, whatever it is, as pen, whatever tablets platform you're using. All right. But it must be on your own, in your own handwriting. No typing. Okay. And PDF format, please. Okay. So this is part of the process. Yeah, you learn. All right. Get moving. Hey guys, can you guys see the assignments menu yet? Is it up? Anyone can see?
We can see the PDF file, sir.
You can see the PDF. No. Go to the more and in the assignments tab. Is it posted?
No, I do not post it yet. I cannot
It's not
see it.
yet, sir.
Oh, okay. Let me fix. I'm trying to see that too. I think something's not right with the team.
Excuse me, ครับอาจารย์
Yeah,
Does the file have to have a format?
PDF, please. Yeah.
Only that, อาจารย์ no need to change any name.
Yeah, you can say assignments 1, EE 2401, assignments 1.
โอเคอาจารย์ Thank you ครับ
ครับ Huh. I think something's wrong with team. Give me 1 second. How do I do this? Okay, have you guys see the tab yet? I can't see mine on my part.
No, sir.
Not yet?
No.
Okay, if you are done, then let's do it like this. I'm not sure if something's wrong with the server. Maybe I can't. I tried to set 2 assignments already. Can you send me personally to my name, my account? Martin, you done, right?
Yes, Kabajan.
Yeah, to try and send it privately via team to me, see if that works or not.
Okay, Kabajan.
So that I can check, because I can't seem to set up the assignments tab. It's showing me, but it doesn't say, it doesn't show you guys' names. Okay, in the meantime, I'll try to work out the solutions. Okay, so that way you have it right away once you're done. Okay, great, Martin. I got yours. Okay, so everyone, if you cannot see your assignments tab, submit to the private chat. Okay, so that way I receive your homework.
Excuse me ครับอาจารย์ it says that it's error ครับผม I don't think you can download it ครับ It's-
Really? Hang on,
ใช่
let me
ครับ
check. Give me a second. Oh yes, show me an errors. Can you try that again?
I'll try ครับอาจารย์
Ajahn, where do I submit?
Privately. Try to do it in a chat.
From MS Teams, right? Not from line.
Yeah, in team.
Okay.
PDF.
Okay.
Martin is trying to do it too, but he had an error uploading the file. So when see you guys do have the same problems.
And John, my one also says error while uploading the file.
Okay, it seems that everyone is having some problems. Hang on. You guys, you have line, right? Try send it to line, our group. See if I got it or not. Martin, you do the same.
โอเคอาจารย์
Teacher, could you try to make a file on Files tab? Because most of the other teachers does the files there.
Yeah, yes, already uploaded. The assignments, you mean?
Not assignments, Ajahn, under the Files tab.
Yeah, it's
Like-
in the file already. Did you check? The assignments are in the file because I posted in the general post.
Ajahn, I tried submitting in a JPEG format, and I think you must have received it.
Hang on, let me check. If it's in the picture format and it works, then we don't have to do it via line. That would be better. Give me a second.
Okay.
Okay, just got disconnected. I'm just back on. Hang on, let me check. Okay, picture's good. So, yeah, Mohammed, you sent me a picture, right? I got it.
Yes, sir.
Yeah, so everyone else, send it for this time only in JPEG or any kind of picture format, private chat, because the assignments tab doesn't seem to work, okay? All right, Martin, you do the same, please. So that way I can have records on every one of you in the server of the team instead.
Achan, if I'm not finished, I have to submit that I do, right?
Yeah, submit everything, submit anything that you have. You don't have to finish. Just give me something. You have until 2:30. Okay. 5 more minutes. Try to do as much as you can. But if you have something, submit before the due time. Okay. Seems to be a problem with the assignments tab in Teams. So
Excuse me, sir. So we
yeah,
have to submit on personal chat with JPEG, right?
yeah, any kind of picture format. I think PDF doesn't work. I don't know why. Something's not right with the team. Okay, so picture would be good. I got your friends' pictures, so that doesn't seem to be a problem.
Achan, we can submit until 2:30, right?
Yeah, 2:30. And my name, you guys, we just ask. It's in the participant. Wisawat, I'm the organizer of this team. WP. You should see my name on the post, right? Fukandi, you see my name?
Teacher, I was thinking to send you pictures through line.
The line, no. Do it in our general, in a private chat.
Okay.
Via team.
Sir, I already sent it in private chat and check.
Yeah, I'm gonna check all you guys now. Okay, now these are the person who I got. It's pretty slow. I got Jimma. I got. Give me a second. Just loading. Oh, PDF seems to work too. Just now. Furkan, right? How do you pronounce your name? Kokoi, right? Is that right?
Chokoi, actually, Ajahn, but doesn't matter anyway.
What is your nickname then?
It's just Furkan, Ajahn.
Furkan, right? Okay, I got yours. Checking Ahmed now. Hang on. Adam. I got Ahmed.
Yes, Ajahn.
Yeah. Ahmed Adam. Hassan, okay. Hyunmin, I'm checking yours now.
Yes.
Okay, got yours. Canisia. Hang on a second. I got yours. Rithipong, I'm checking yours now. Got it. Nachapon. Got it. Martin. I got yours. Mohammed Abshan. I got yours. Okay. Jimma. Got it.
Thank you, sir.
Alito. Hang on, loading. Okay, got it. So the rest of you guys, please try to submit on only within 2:30. Tatiya, is that right? How do you? Is it,
Yes อาจารย์
คนไทยปะเนี่ย
คนไทยค่ะ
ชื่ออะไรอ่ะ
ตัตติยาค่ะ
ทัตยาเหรอ
ตัตติยาค่ะอาจารย์
Tatiya, okay, got yours. And Sili เหรอนี่คนไทยปะ6237307 Are you Thai
คนไทย
ชื่ออะไรคุณชื่ออะไร
กล้องครับกล้อง
กล้องไม่แล้วชื่อจริงชื่ออะไรเนี่ย
สิริภพครับ
สิริภพใช่ไหมอ๋อโอเค
สิริภพครับอาจารย์
สิริใช่ไหม
ครับสิริครับ
สิริภพนะโอเค got yours you Shang hang on you Shang yeah try to submit it within the next 5 minutes. Okay, the rest of you haven't submitted, please do it now. Whatever you have. Okay, it doesn't have to be perfect. Just give something to me, okay? All right, now let's I'll wait a few minutes. So that way we'll talk about the solutions a little bit. Haven't really done the calculations yet. Just gonna hang on a second. Okay, if you haven't submitted, please do so by now. Okay, I'm gonna go through the solutions right now. Okay. So this is the one that you should have. Okay, so it's not really complicated when you know the length. Okay, so the hard part is how do you determine the associate length with the reluctance. Okay, so here I crudely draw the dimensions here, but you have that on your own already. Okay, so I also give you the magnetic circuit. Okay, all right, so our left. Our left is, of course, if you look carefully, let me go back to the picture. It's this part right here, right? From the middle of this leg, and then the middle of the center leg. Okay, so it's 9 divided by 2 plus 25 plus 15 divided by 2. Plus top and the bottom. So I multiply that by 2. So this is how I got it. 9 divided by 2 plus 25 plus 15 by 2, top and bottom, so that's times 2. And then on the right edges, again, 9, so it's here to here, which is 9 divided by 2 plus 25 plus 9 divided by 2. Okay, so I added that, and remember these are in centimeters. You do this, you should get 1.08 meter, okay? And remember, the generalization of the reluctance is length divided by mu A. So my mu is my mu R, 2000, mu naught. And then the cross-sectional area of this path only, which is 9 times 5. See, 9 times 5 meters. Convert to centimeters, 10 to the negative 4th. Do that right, you should get about 95.49 kiloamperes turn per Weber. Okay. And again, if you look closely, the right flux path is identical to the left path. See, again, 15 divided by 2 plus 25 plus 9 divided by 2, 9 divided by 2, 25, 9 divided by 2, and then same thing, top and bottom. So it's identical path. So meaning that the right flux reluctance, right leg reluctance will be the same, 95.49. Okay, now, so we got that, which leaves us the center leg. So you look at our center. Our center is, of course, this distance here. Hang on, I'm off screen, which is 9 by 2 plus 25 plus 9 by 2, which is 34 centimeter or 0.34. Again, divided by 2000 mu naught. But here is, you have to be careful here. I made an error there. I was in a hurry. I just remember that I did it wrong. The cross-sectional area is this depth. See, so it has to be 15 times 5. See, this cross-sectional area here. This is 9. This is 15, so it has to be 15, the width and the depth, and then 10 to the 4th. And I gotta get a calculator. Again, if I'm wrong, let me know. I didn't really have time. Hang on a second. Should be. Second, let me write this down. Should be 0.34 divided by 2 times 10 to the 3rd mu naught times 75, 10 to the negative 4th. Okay, and what is that? 3.4. Hang on a second. I got this. Give me 1 second. Let me double check. I got 530. That's too small. I got what do you guys get? I got 1.8. Is that right? I need to double check my numbers. Okay, I'll come back and give you the numbers next time. Let's see. Hang on. Why is you guys see my screen now? Okay. So 34 centimeters, which is 0.340 divided by 2,000 mu naught. 5 times 15 is 75. 10 to the 4th meter square. Let me check that. 0.34. So it's about 18.04 kiloamperes turn per Weber. Okay, so that's the center leg. Now the air gap is 0.00, 1, 2, 3, 4, 5 times to the negative 4th meters. Okay, and then mu naught, and then again the cross-sectional area is the same as the center leg. So it has to be 15 times 5 times 10 to the negative 4th meter square. Okay, now we have no fringing effect, so you don't need to multiply it with anything. Okay, what is this going to be? Oh, let's check that. Let me. So five to the negative 4th, so it's 5. Cancel, so 1 over mu naught times 15. So what is that? 4 times pi times 15. Should be, again, I got to double check the numbers. I'll give you if it's right. It's okay, 53.05 kiloamperes turn per Weber. Okay. So this is what we got, all 4 of them. Now the point is we have to find the final equivalent circuit. So it should be something like this. Right, this is the magneto force and a turn time the current. This is Req. Again, to get the right Req, you have to look at the setup earlier. So it's just center leg in parallel with the right, in series with the left. Okay, this in parallel with that, so it is equal to, let me do that, R left plus RC plus RG in parallel with R right. Okay, this in the bracket here equals to R right times RC plus RG divided by the sum, which is R right plus RC plus RG. Okay, so the final one would be R left plus R right times RC plus RG divided by R right plus RC plus RG. Okay, so if you do this right, it has to be, wow, that's a big number. 95.49 K. 95.49 K times center is 18.04 plus 53.05 K divided by the sum of all three, 95.49 plus 18.04 plus 53.05 K. Okay, K cancel. So what is that number? Again, if I don't have the same number, you can just shout, because I want to know. I'm doing this in a hurry. So here in the bottom one, this is equal to 166.58. Okay. The top one. This is 6788.38. So it becomes 95.49 K plus 40.75 K. Is that right? I'm not sure. Again, I'll come back and recheck these numbers again. (136.24 kilo amperes turn per Weber). Okay. Okay. Now, once we got that, we can find the flux here, and you have to keep in mind this flux is according to the circuit, which is our phi left. Okay, so this is phi left. So you have your first answer. So therefore, your phi left becomes the magnetomotive force divided by Req, which is 200 turns times 2m, I think, right? Yeah, 2m, 100 turns, sorry. 2m divided by this 136.24 K amperes turn per Weber. Okay, so 200 divided by 136.24. 1.468 10 to the negative third Weber. Okay, so that's your first answer. See? Now, we have to use the circuit again to find the center and the left. I'm sorry, the right. Okay, we know that phi center is equal to phi left minus phi right from this note here. Remember, this is phi left. Okay, and we also know that like a current divider, the product of phi C times the center must equal to phi R times RR. Okay, so we have two equations. So we know that phi C times RC plus RG must equal to the right times R right. Okay, and then we have two unknowns, which is C and right, two equations. So you can solve So this time I'm going to solve phi, let's do phi C. So I substitute phi C in here, so and let's do phi R instead. So this gives you phi R is phi left minus phi C. Put it back in here, it's going to be, you expand that, it's going to be phi L R minus phi C R. Okay. Rearranging this, you should get phi C times RC plus RG plus RR equals to phi left times RR. You can use, you can use that if you know the voltage divider or current divider, you can just use that directly. If you understand, I'm just showing you the process here. And we know each of them, so this is equals to, therefore, your center leg is equal to the right divided by right plus center plus the gap times the left. Okay. And if you do this right, this is our right 95.49 K divided by the sum 166.58 K. Okay. And then phi right, which is this one here. I don't have space. Okay. I'm running out of space, so I'm just going to point it out. How's that going to be? Times 95.49 divided by 166.58. You should get 0.842, 10 to the negative third Weber. And finally, your right is 1.468 minus 0.842, 10 to the negative third, which is what? 1.468 minus 0.842. 0.626 10 to the negative third Weber. So these are the three answers that you have to solve. Okay. Now, if I'm not sure, I can always double check. Okay. Manipulating that in a reverse manner, meaning instead of finding here phi C, I can find phi right. Okay. You have time? Let's do that, and then you can do that on your own. Okay. If we do that, I can say instead of this, okay, here, I can here right here. I can say phi right equals to R center plus RG divided by RR plus RC plus RG times phi L. Okay. See, we got that. This becomes, what is the center? I forgot. 53, right? No, 18.04 plus 53.05 K divided by 166.58 K, 1.468 and then 8/3. See, we got that. If we don't, something's wrong with our calculations. 18.04 plus 53.05 divided by 166.58 times 1.468. Yeah, so it's the same, 0.626 milliweber. See, so must match that number. Okay, you can do it there, but here's kind of like a more calculations. Okay. Okay, so I'll double check on the numbers. Okay, if it's not like what I have here, I'll let you know next time. Okay, I'm out of time, right? Yeah. Okay. So hopefully most of you submit your first assignment. Okay, at least have some, something to work with, try to do this on your own and understand what we're doing. I'll repeat again, similar problem like this will be in the midterm exam, okay? So make sure if you haven't done it right this time, make sure you fully understand what we are doing, all right? Any question? Seems a little bit clumsy, our first assignment. I don't know what happens to the team server. I cannot set up the tab assignments. We'll try that again on the second assignments, okay? Any questions or comment?
No,
อาจารย์ did you receive my assignment อาจารย์
Hang on. Okay. If I call your name on the first batch, you can go. I'll check the rest, okay? Hang on a second.
Ajahn, I have sent you on private chat in MS Team. Ajahn, I didn't find your line, personal line. So
yeah. Don't do it via line. We want to do it here. Everything has to be done here. Okay.
Okay.
Here's the latest that I got from you guys. I got from, hang on, let me check. Simon, I got yours. Tira Pat, hang on, it's loading. I got, hang on.
Ajahn, did you get Jonggon Lee ones?
Yeah, hang on. Hang on. It's very slow. Okay, I got. Why is it very slow? I got disconnected. Okay, I'm gonna call the names that I got. I got Simon, I got Tirapat sending me. Okay, I got Jayan, right? Yu Shang, Furkan, Jongwon, I got yours. Prin. Okay, and Chayut. Okay, that's the latest that I have.
Ajahn, that's Furkan Chokoi, right? Because there are two.
No, another Furkan, Simsek.
Oh, okay.
I got yours already, Furkan Chokoi.
Okay, Ajahn. Okay.
Yeah, you're the first batch that I call.
Okay, Ajahn. Okay.
All right. That's it. That's all I got. The second batch. And Ahmed, you just send me a new one now.
Yes, again, the first file I think is couldn't open. I think you cannot open it, that's why.
Okay, that's okay. All right. So that's it. If you submit me and haven't called your names, let me know now. I'm gonna disconnect now. If there's no more questions or anything, I'll see you again next week. Oh no, not next week. Thursday. All right. Okay, I'll double check on the numbers for the assignments, so that way, and you know what's gonna, if it's right or wrong. All right. See you on Thursday. Bye.
Thank you, Ajahn.
Thank you.
Thank you, sir.